won't be catching feelings. But she got me catching feelings. I can't be catching feelings. But she got me catching feelings.
Hi everyone, what's up? It's your boy Trix. Today we're going to be doing some more Rust Rogue. I had some ideas for what I can do in the channel, and I was just going to bring that up today for like how my content might change. I'm still going to be live streaming obviously, but if you watched in my last live stream, I was talking about how I pretty much completed the Java developer roadmap. Obviously I haven't touched everything on there just because like maybe the tutorials were a bit iffy or something like that, but for the Java roadmap specifically, I've touched the majority of things and I understand the majority of things there. So we have moved to the backend developer roadmap, and then because of that I have also stopped doing the Java streams, and I used to do 1 day of Rust streaming and 1 day of Java streaming, right? I'm currently doing Java at work, so I done that to like supplement my outside of work learning. Now I'm doing Rust, and I'm still looking at the developer roadmap. I'm still looking at the backend developer roadmap as well, so I'll be covering things there if it's like programming related. But they do not have every language there, and I'm pretty sure they do not have a Rust one. So if I go on to roadmap.sh, and then this one's backend, so it should just be Rust if there is a Rust one. I'm pretty sure there isn't a Rust one. Yeah, there's no Rust roadmap. So because of that, I have been very hesitant to try filling up space for what to do in Rust, and I don't want to pick up another language because I'm already doing Rust alongside Java, and if you start adding in a ton more languages to that, you start getting confused. So what I was thinking was of doing the rustlings exercises. So I'll start a stream and end a stream with rustlings, just one exercise in rustlings, and then I will do the build a game in Rust during the middle of the stream. This is just because I feel like with my previous learning of Rust, I haven't really done that much learning. It's mainly just been me reading or copy pasting and stuff like that, and I'm hoping that if I do rustlings, I will be learning a lot more, if that makes sense. And I do know I said in a stream a while ago that I wanted to do how I was going to do the developer roadmap for the backend one at least. So if I go to the, it's going to be a pain to get back to rustlings, but there are some languages here that I do want to go through. But there is also the Stack Overflow survey. Can't spell. Sorry about that. And the developer survey for 2022. There we are. So this is the developer survey for 2022, just talking about the most used technologies and stuff depending on the developer. So if I go to technology and the most loved, dreaded, and wanted, I have been learning Rust, and on this roadmap you can see there's Rust, Go, Java, JavaScript, C#, Python, PHP, Ruby, right? Rust I've been doing, which is why and I purely picked up Rust because of this, right? So I'm thinking of going in order from here, right? So I'm going to be doing Rust, then Elixir, then Clojure, then TypeScript, Julia, Python, Delphi, Go, SQL, C#, Kotlin, Swift, all the way down, right? Of course, some of these things I may not be able to cover if I can't find good resources on it, but I'll still attempt to try and learn it on stream. For some of these, I do know, like, I know Python, I know SQL, I know Dart, I know some HTML and CSS. CSS is a bit of a stretch. I know Java because I'm using it at work. I've done a little bit of PHP. I know C. Yeah, those are the only ones there that I can list off right now. I also do know some Lua. I don't even think Lua's on here though. Yeah, Lua is on here, but I'm not going to count Lua because I only use it to configure Vim and I'm near Vim and I don't really use it outside of that. So I'm not going to count it. But I will attempt to do these things. So I'm hoping that if it's on the roadmap here, so if I go to roadmaps, I could do the Android one. I'm pretty sure Kotlin is on here. Yeah, Kotlin is on here, right? I could do the Android one. I could potentially do the DevOps one, just because DevOps does include Ruby, JS, Rust, Go, Python. Then I could maybe do blockchain. Probably has Rust here. Oh, doesn't it have Rust here? Interesting. It's mainly just it's just got Python, Go, and JavaScript. Very interesting that no other languages are there. Anyway, I could do Flutter as well, but Flutter I haven't really touched in a while. The majority of this I have covered already. Interestingly, I could probably like knock some of these off right now, but I will do it when it comes round to it on the Stack Overflow survey. And then some of these, yeah, I have done the Java one. If I go to it, if anybody hasn't seen it, if it loads, I have covered quite a few things on here. Spring Data JPA, I could probably just like mark it done because there was a tutorial that I did on that. Everything else, not really. Again, mainly because of either the quality of the tutorials or something like that. Spark, I don't really want to count as I've learnt it, but I did look over the tutorials that were there and it looks okay from what I have seen. But yes, I am planning to do Rustlings just so that I can get better at Rust, and then when I come across something, I will hopefully do a stream on it. So, with that being said, if there is a Rust roadmap that does get added to this, I will probably go through it anyway. But I'm planned to only do at least 2 languages at a time. The language that I'm currently working with, and then the language that I'm learning outside of work. If something does come up, I will hold off on the current language that I'm using, on the current language that I'm learning, and switch back to a language that I was learning before, if that is possible. But I will prioritize consolidating knowledge instead of learning new knowledge, if that makes sense. So, if I just load up Rustlings again. Rustlings. There we go. Cool. So, getting started, if you're on Mac, make sure you install Xcode, that's fine. So, that's just saying, well, if you want to install it, install Rustling, give you access to Rustling. Come on. Cool. So let's install the Rustlings first. So let me run this. I'm hoping it doesn't install to this directory. Ah, oh, fuck. Install this one. Hang on. RMR Rustlings, let me go to here. If I cd into programming, call, and then I do the same command here. There. Just taking a while. I'm just going to save this to coding, yeah. There we go. Takes a while, doesn't it? Well, it's downloading a ton, so that makes sense. I had the 97 exercises or 95. I'm hoping to do at least 2 per stream. So I have around 40 something chapters left. I know there's I think 75 chapters of Rust Rogue. I'm on chapter 29 so far. So I'm just gonna get out a calculator because I can't be asked to do that in my head. 5 minus 29 equal 46. So if I do 2 per stream, I might need to do 3 per stream. Because 2 per stream will get me to 92. It should be alright. It should be alright. Or I could just do Saturdays are Rust Rogue days and then Sundays are wrestling days. But I'd rather do wrestlings than Rust Rogue than wrestlings again. Just because I feel like that would be more enjoyable. That I'm context switching between them. And then I'll be able to cover more of Rust Rogue and more of wrestlings at the same time. If you have any preference that you want me to do, please drop it in the comments or give me some advice. That being said, I'm planning to pick up Elixir next because Rust is up top, then Elixir is right after it. And I've been looking at Elixir, like the docs for it. Docs look okay in comparison to like other languages I've seen before. Like the Python ones are just known for being bad. The one for Java isn't that bad. I prefer the Java tutorials to the actual like Java Oracle tutorials to the actual Java documentation. But it's not that bad in comparison. But the one for Elixir, I found that the tutorials for it there aren't that many free tutorials. Most of the stuff I've seen for Elixir are like behind a paywall. So if anybody has like good resources for Elixir, that please check that you have cargo pin in your environment path. Let me just check. Oh, of course it's not there. Wrong one. Okay. I can't. Oh, I'm gonna have to source my. I'm gonna have to. Okay. Let me. I'm trying to remember if I do have that in the path. Yeah, I do. Local bin. Oh, cargo. .cargo/bin. There we are. Cool. Okay. The I am not done comment. Okay, so if I and then I rustlings LSP just so I can get rust analyzer and then VI, and then I go into exercises and then which one is it? It's intro and then intro 1 and then remove I am not done. Okay, so this is intro 2. One positional argument in format string, but no forgiven. Watch mode, you can type help, aborting due to previous error. Okay. So, what I need to do is, I need to do... Yeah. Oh, am I not able to edit here? Oh, so you need to quit and then you need to... Okay. Oh, whoops, it's $. It is, and then it's... Whoops, it is this one, and then... And then if I do... There we go. Not found in scope, okay. This is in what? Variables, cool. So now I'm in a different, now I am doing a different exercise set. I'm going to switch back to Rust Rogue. Season to Rust Rogue. Cool. Now, if I VI into Rust Rogue, cool. So, if I go to Mazes and Labyrinths, in maze.rs, and you just need to chuck in all this. Cool. And then in mod.rs, I just need to make random builder always return this, which is simple. I can just go to this line, jump up 12, and replace. And that's why you always enable relative line numbers in Vim. Actually building a maze. There are lots of good maze building algorithms out there, all guaranteed to give you a perfectly solvable maze in one night in the dungeon. I based my maze building code off of a relatively standard implementation. Sayusilin's maze generator. It's an interesting algorithm because like a lot of maze algorithms, it assumes that the walls are part of the tile grid. Rather than having separate wall entities, that isn't going to work for the type of tile map we are using. So we generate the grid at half the resolution of the actual map and generate walls based upon wall adjacency information in the grid. The algorithm started as C++ code with pointers everywhere and took a bit of time to port the most basic structure in the algorithm, the cells or tiles on the map. We define four constants: top, right, bottom, and left, and assign them to the number 0 to 3. But where does this go? We use these whenever the algorithm wants to refer to a direction. Looking at cell there is relatively simple. Row and column define where the cell is on the map. Yeah, because it's just X and Y. Wall is an array with a ball for each of the directions we've defined. Rest array is static. You can't resize them like a vector, are defined with the syntax type number of elements. Most of the time we just use vectors because we like dynamic sizing. In this case, the number of elements is known ahead of time, so using lower overhead type makes sense. Visited a ball indicating whether we previously looked at the cell. Okay. Cell also defines some methods for us as an constructor. We can cell with walls in each direction and not previously visited cells. Also define a function called remove walls. There's some new stuff here. We set x to our column value, okay, minus the column value of the next cell, okay. We do the same with y, but with the row values. Yeah, that makes sense. If x is equal to 1, then the next columns must be greater than our column value. In other words, the next cell is the right side, is to the right of our current location, so we remove the wall to the right. Likewise, if x is minus 1, then we must be going left, so we remove the wall to the left. Once again, if y is 1, we must go up, so we move the wall to the top. Finally, if y is -1, we must be going down, so we remove the walls below us. View cell is done. Now to actually use it in algorithm cell is part of grid. Here's the basic grid definition. Okay. That's a lifetime. Yeah. Basically, Rust has its own garbage collector. Well, it's called a borrow checker, but it's basically a garbage collector that if it hasn't been used in a while, it'll just remove it. But obviously, if you're using an item and you know you're going to be calling it after a very long time, you want to make sure that it will be kept alive till you call it. It won't just be collected once something's been called on it, and that you will never be able to call it again. So you use a lifetime to say, hey, I want to use this. Don't delete it yet until I've called it, right? I read that from the backend. No, was it the backend? No, was it the backend one? It was the backend developer roadmap in the memory management section on the OS block. There's a couple blog posts in there, and one links to a dev.to article, and in there it covers different GCs. The one for Java is just about Java, so it's not that bad. If you've done programming, you probably either come across the C, C++, or Java GCs. It also talks about V8, which is JavaScript's one, the borrow checker, which is Rust one, and then I've forgotten what the Go's one's called. Hang on, I can Google it actually. Go's GC. Go GC. I hope like Google can. System is no longer needed yet. That's basically the same as the one in Rust. They all use some type of reference counting. I don't. Does it have a name? Is GC %? Yep. Because in Java you have G1, ZGC. Beldung has a good article on them. Beldung GC. I keep forgetting their names. JVM garbage collectors. Here we go. So you got, yeah, you got, there we go. You got G1, you got ZGC, then you have CMS, parallel, and serial. Serial is slow. Oh, okay. Example. Serial is slow because it has to do everything one after the other. I.e., not a good idea if you're using a multi-threaded application, because each of your threads will have to wait while the other thread is collecting, right? Then you've got the parallel one, which is better if you're using multi-threading because it's not always waiting for another thread to finish. You'll be able to run garbage collection on multiple threads at the same time, right? Then you've got CMS, concurrent mark sweep, multiple garbage collector threads for garbage collection, prefer short garbage collection pauses, confirm, yeah. Then you've got the G1, which is the most common one that is used in most places. Then you've got ZGC, which is supposed to be known as the like fastest one, where your collections are very fast, but it does them more frequently. So it's better in applications where you know you're not going to need long lifetime elements. I mean, long lifetime objects. from what I've seen, if you're allocating lots of objects repeatedly and you need them to get collected, let's say you're always spawning new objects and you don't need to access the objects that you previously spawned afterwards, which is very common if you're using like records or something, because you're going to use that record and maybe just discard it afterwards, right? You'd want to use ZGC because you don't want those objects to get into like tenure or S0 or S1. You always want them to stay in Eden. Oh, I realize some people might know what Eden space is. Basically, you don't want them to live long enough that they just don't get collected by the garbage collector. So you want collections to happen fairly frequently, which is why you'd want to use something like ZGC for objects that you want to give a chance to get into tenure or S0 or S1. You want to be using something like normal, like G1 or CMS or Parallel. I've never used CMS or Parallel, so I can't really talk about the experience of those. But with G1 at least, garbage collections don't happen as they don't happen as frequently as in ZGC, but whereas ZGC the actual pauses between garbage collections are very short, but you're having more frequent garbage collections. Whereas with G1, you will have larger garbage collections and larger pauses. Not larger, you will have less garbage collections but longer pauses, right? So objects will start getting into maybe tenure or S1 or S0 space instead of just staying in Eden. So you're giving the opportunity for objects to live a little longer. So if you want frequent object collection, then you'll use ZGC. If you want objects to live a little longer, maybe you're going to be accessing objects in a longer period of time, kind of like with lifetimes, where you want to say that, hey, you want to be accessing objects further down the road instead of just having it being collected immediately, then you want to use like something like G1. That's like the Java equivalent, from what I understand. I didn't think I'd get Java into a Rust stream, but I did. Oh, nice. I realized I went on a tangent about GCs. Anyway, I do recommend reading that article. It's in, I think, 5 to 6 parts covering different GCs. I do highly recommend reading it. If you want to specifically read up on a specific language, if it's Java, I do recommend the Beldong post. It's very, very good when it comes to explaining what the GC does and how they compare, and just talking about what each one does. For other GCs, I'm not sure, because Beldong doesn't really cover any other languages besides Java and then his like Linux blog post. I don't know if he does have another one in another language, but there's probably blog posts out there covering it. If you just want like a brief explanation, that's pretty good on how memory gets allocated and released with each of the GCs. The dev.to article on the backend developer roadmap on roadmap.sh is pretty good. It's pretty quality. And so once again, we had to use some ugly syntax for lifetime. The constructor itself is quite simple. It makes a new grid structure with specified width and height, a new vector of cells, a new empty backtrace vector set current to 0, and stores the random number generator reference. Then it iterates rows and columns of the grid, pushing new cell structures to a cells vector numbered by their location. The grid also implements calculate index. This is very similar to our maps xy idx function. It takes row and column coordinate and returns the array index at which one can find the cell. It also does some balance checking and returns -1 if coordinates are invalid. Next, we provide get available neighbors. This function provides the available exits from current cell. It works by obtaining the row and column coordinates of the current cell and then puts a call to calculate index into an array corresponding to the direction we defined with cell. It finally iterates the array and the values are greater than -1. Yeah, and if the values are valid greater than -1, sorry, and we haven't been there before, the visitor check, it pushes them into the neighbors list. It then returns neighbors. A call to this for any cell address will return a vector listing all of the adjacent cells to which we can travel, ignoring walls. We first use this find next cell. This function is interesting in that it returns an option. It's possible that there is nowhere to go from this current cell, in which case it returns none. Otherwise, it returns some with the array index of the next destination it works by. Obtain a list of neighbors for the current cell. If there are neighbors, if there is only one neighbor, return it. If there are multiple neighbors, pick one and random and return it. If there are no neighbors, return none. We use this from generate maze. So now we're on to the actual algorithm. Let's step through it to understand how it works. We start with a loop. We haven't used one of these before, but you can read them here. What do you mean? This loop. Okay. Basically, a loop runs forever until it hits a break statement. So it will hit. So when it hits the none option, and it's a self.backtrace. If the backtrace is empty, you'll break. Otherwise, you'll just keep continuing. Cool. Set the value of visited in current cell to true. We add current cell to the beginning of the backtrace list. So I'm guessing loop is just a while then. We can find next cell and set its index in the very one. This is our first run. We'll get a random direction from the starting cell, otherwise we get an exit from the current cell we visited. If next has a value, then split cells to two mutable references. Well, we will need two mutable references to the same slice, but Rust normally doesn't allow this, but we can split our slice to two non-overlapping parts. This is a common use case, and Rust provides a safe function to do exactly that. Get mutable reference to the cell with lower index from first part and to the second from start of second part. We call removals on the cell 1 cell referencing the cell 2 cell. If next does not have a value, it's equal to none. If backtrace isn't empty, we set current to the first value in the backtrace list. If backtrace is empty, we finish, so we break out of the loop. Finally, we call copy to map, which copies the maze to the map. More on that below, and take a snapshot of the iterative map generation window. So why does that work? The first few iterations, we'll get a non-visited neighbor carving a clear path through the maze. Each step along the way, cells will be visited as added to backtrace. This is effectively a drunken walk through the maze, but ensuring that we cannot return a cell. When we hit a point at which we have no neighbors, we've hit the end of the maze. The algorithm will change current to the first entry in our backtrace list. It will then randomly walk from there, filling in more cells. If that point can't go anywhere, it works back up the backtrace list. This repeats until every cell has been visited, meaning that the backtrace and neighbors are both empty or we're done. Okay. Finally, here's a copy to map function. This is where the mismatch between grid cell and our map format is resolved. Each cell in the maze structure can have walls in any of the four major directions. That makes sense. Our map doesn't work that way. Well, walls aren't part of a tile, they are a tile. So we double the size of the grid and carve floors where walls aren't present. Let's walk through this function. Okay. We set all cells in the map to a solid wall. For each cell in the grid, we calculate X as the cell's column value +1, calculate Y as the cell's row value +1, set IDX to map.xy_IDX of double the X and Y values, so spread each cell out. We set the map tile at IDX to be a floor. If the cell we're referencing does not have a top wall, we set the map tile above our IDX tile to be a floor. We repeat that for the other directions. Speeding up the generator. We're wasting a lot of time by snapshotting every iteration. We're building a huge list of snapshot maps. That was great for learning the algorithm, but simply takes too long when playing the game. Yeah, because you keep adding to a massive list of maps because you keep snapshotting each iteration. That makes sense. Modify generate map function to count iterations and only log every 10th. Okay. Application 2.2. So in build, we can easily specify a starting point. Okay. I wonder where all of this code went. I'm assuming it's all just gonna go in maze. Let's take a look. Yeah, just all went in maze. Cool. I just need to mod maze and then use maze colon maze builder. Just need that to build. That's fine, it's just because I've not enabled them. Come on. Takes a while, doesn't it? And there we are. Let me just cargo run. Just want to see the map generate. There we are. Cool, so now if I begin the game, I'm in the top of the map. Well, that's fine, isn't it? Just to understand how the game works. SRC, map, mod, and then just overwriting this random builder, BGP, and then cargo build again. Come on. Okay. Whoops. There. Mazes and labyrinths. Beavers. There we go. Scaffolding. Actually building ways. Restoring the randomness. Chapter 30, which is diffusion limited aggregation. There we are. So if I go back to rustlings, so I need to go into variables 1. Variables 1. This isn't in scope. How? Oh. No. Why isn't that in scope? Oh. I'm missing a let. I think I'm missing a let. I say that. There we are. Hang on one sec.
We ain't gotta keep this on the low. Don't do it fast, we can take it slow. Show you things that you ain't seen before. Before you go, you ought to know. I won't be catching feelings. But she got me catching feelings. I can't be catching feelings. But she got me catching feelings. we in. We coolin' for the weekend. Drop the top and then we out. We do this every season. Sunshades on a sunny day. Doing 80 and we switching lanes. Just keep it cool and chillin' with the bay. Don't call my phone, I hear what you say. Oh, what you say. We ain't gotta keep this on the low. Don't do it fast, we can take it slow. Show you things that you ain't seen before. Before you go, you ought to know. I won't be catching feelings.
Sorry about that, my mum just called me. I'm just gonna do Rust C explain because Rust. Sorry about that. Why is it set to fade? I want it to. Transition. Sorry about that. Explain. EO 282. Oh, this is just types. Cool. Oh. I thought that was a silent operator, sorry. It's this, right? I don't know if it comes before or after. Yeah, cool. Oh. Oh. Oh yeah, because all objects in Rust are immutable by standard. So let my x. Yeah, there we are. I'm probably just gonna do one module per stream, probably, yeah. Hang on. Expected use of this value. Okay. Expected Anstra found Instra. Okay, so cannot add to Anstra. Minus integer. Number equals 3. Number equals 3. Don't rename this. Don't change the sign. Okay. So I'm not allowed to make that mutable, because if I make that mutable, then I can reassign the element. I might need a hint, yeah. There we go. Oh. No way is it this simple. Damn. It is. Yeah, because you're saying it's mutable, so you're saying, hey. Okay, so the way that I understand this is, if you just use normal let spaces or whatever, like this, you're overriding the previous assignment, right? So you're saying, okay, this is an empty string, right? Now you're making a new variable of the same name, but you're taking the previous variable and getting the length of it. So this will still run fine. Gives you however many items it is. I'm guessing it's 3. 1, 2, 3. Yeah, it'll give you 3 in here and store it as this. But if you're doing it as mutable, mutable means that you're changing the original value instead of making a new one. So this isn't possible because this is a string and this is going to be an integer. you can't assign a string to an integer, but you can overwrite a variable, and by just saying, oh, you want to have that variable be immutable anyway. If you want it to be immutable, means that you want it to change. Immutable means you do not want it to change at all. Basically, you can update the value of an immutable object, I believe. Mutable means that state can change. Immutable means that state can't change. So I don't think you can update a value of a mutable object either. Oh. Well, it told me what to do. Cool. So that is the first 8 exercises done. If we go at this pace, that means 8 so that's 75 minus, let's say 30 to make it a little easier. So that's 45, right? So 94 minus 8 divided by 45. I will have to do at least 2 exercises per stream, and I think I can do that pretty okay. So tomorrow we're going to be doing another rustlings, and then Rust Rogue, and then rustlings again. Anyway, thanks for watching. Hope you had a great day. Like, subscribe, enjoy the rest of your day, and peace.